to see one method of how to derivate the centripetal acceleration. So here we have this is the object that is moving around a cycle, so has this circular motion. We have that this is the position of this particle at this moment. Could also be in this point, wherever it be. But this is the distance from the center. We can call this r, and this distance has these two components, the x component and the y component. That these components are r times the cosine of the angle, and this is r times the sine of the angle. So we can write that the position of this particle is r cosine of theta times the unit vector I plus r sine of theta plus the unit vector j. Now if we take the derivative, so first let me put it as b of t r times cosine of theta times the unit vector I plus sine theta times the unit vector j. So now if we take the derivative, so the p on the t, that this would be the velocity vector. We have the p on the t would be r is just a constant, so r times the derivative of this. The derivative of this is minus sine of theta times the derivative, so the theta in the t times the unit vector I plus cosine theta times the theta in the t times the unit vector j. So we can, well, in previous video we saw that the theta on the t, this is the angular velocity. So we have that the velocity is r omega, actually let me switch signs, so minus r omega times the sine of theta times the unit vector I minus cosine theta times the unit vector j. Now the square p on the t square, so this is the acceleration, the centripetal acceleration, that is the first derivative of the velocity, would be minus r omega cosine theta, the theta on the t times the unit vector I plus sine theta, the theta on the t times the unit vector j. And we know that the theta on the t is omega, so again we have that the acceleration, centripetal acceleration, is minus r omega squared times cosine theta times the unit vector I plus sine theta times the unit vector j. And this is exactly the position. So have that the centripetal acceleration is minus r omega squared times p of t. So this is p of t. So the magnitude of the centripetal acceleration, this is the magnitude. The magnitude would be just r omega squared. Now what is this? Also we can put this as, we know that velocity was omega times r, so omega squared, r squared would be velocity squared, and if I divide everything by r, I would have omega square r is equal to square velocity divided by r. So this is how we know that the centripetal acceleration is either equal to r times the square of the angular velocity or the square of the velocity divided by